Hey guys. So um, I'm going to this goes along with the 5-4 enthalpies of reaction notes. These are some example problems that I'm just going to work through just to kind of help you guys understand how to do them. So this is sample exercise 5-4 on page 179 in your book. I've got it all written out here, so we don't need to go to the book to see it. But how much heat is released when 450 grams of methane gas is burned in a constant pressure system? Use the following equation. All right, so we've given us a thermochemical equation here, right? Okay, and we're going to do this. Um, we're going to do the conversion for this. Right? Um, Let me check something really quick. Okay, so all right, how much heat is released when 450 grams of methane gas is burned in a constant pressure system? So we're using this idea, and basically, what the concept that they want you to understand is that the subscripts here are not, I said subscripts, I'm sorry, I meant coefficients. The coefficients have a relationship with the delta H of the reaction. So this means, so this tells us that for every 1 mole of CH4 and 2 moles of oxygen, producing 1 mole of CO2 and 2 moles of water, this amount of energy is released. All right. So if we want to calculate how much heat is released when 4.50 grams of methane gas is burned, then all we're really doing is a conversion, like dimensional analysis, like we've been doing. So we've got 4.50 grams of the CH4. Okay. And we're going to convert, because remember the coefficients are in moles. So we're going to convert from grams of CH4 to moles CH4. And this is, what is that? 12 and 4 is 16. Okay. And then we're going to convert from moles of CH4 to kilojoules. Okay. And this, moles of CH4, in front of the CH4 is a 1. And the kilojoules for that are negative 890. So this comes from that. This is from the coefficient. And this is from the delta H of the reaction. Okay, so just do this and do the math. And we get so three significant figures would be negative 250 with a decimal point, nothing after it, kilojoules. Okay, and that would be your answer. Now, on this, I would also accept 250 kilojoules because of the wording of the problem. It says how much heat is released. The negative tells us it's released. So I would actually either take negative or positive. But like if you just use the correct symbols from what's in the equation, you're never going to have it wrong. Okay. All right. That's all there is to it. So let's take a look at the practice exercise from the same page here. Hydrogen peroxide can decompose to water and oxygen by the following reactions. So we got the thermochemical equation with our delta H of the reaction. Calculate the value of Q when 5 grams of H2O liquid decomposes at constant pressure. So remember, Q is the same thing. Q is the difference between Q is heat. And delta H, or H, is enthalpy, which is essentially the same thing. So Q and H we use pretty much interchangeably for most of what we do. All right, so we're looking for heat, which is just going to be energy in like kilojoules or whatever. So we're doing the same thing basically we did up here. We're going to start with the 5 grams of the H2O2. We're going to go from grams H2O2 to moles. All right, and that is 16 is 32 plus 2 is 34. Okay. Then we're going to go, excuse me, from moles H2O2 into kilojoules. And the kilojoule number from here is negative 196. And our moles for H2O2 in front of that as a coefficient is a 2. Right? So now we just do the math. We end up with negative, significant figures are 3, so it'd be negative 14.4 kilojoules. And on this one, okay, you would have to have the negative because it's calculate the value of Q. So Q is a negative number. You would have to have the negative on it. So like I said, if you just always make sure you put the label that's there, like you should be fine. Okay. All right. That's it. Just a couple of examples. If you guys have questions, let me know. Good luck.